In this module, we are going to see more examples that apply linear programming techniques to find the optimal solutions. Recall from the previous discussion that there are three components in optimization problems. The first component is the decision variables. Decision variables are the quantities that a decision maker has control over. The second component is the objective function. Objective function describes the goal of the decision maker. The decision maker will formulate the objective function in terms of the decision variables and choose the best values of the decision variables to optimize the value of the objective function. The third component is the constraints. The constraints are used to describe the capacity, budget, and resource limitations or other rules that the decision maker needs to follow. A major challenge of solving optimization problems is to translate the problem into a mathematical model. Don't focus on memorizing the keywords, style, or the area of application in the examples, because linear programming can be applied to many different industries, various environments, and tons of different settings. The process of identifying the elements in each of the three components will help you get started, and the rest will require good logic. The learning tip for formulating problems into a linear programming model is to focus on teasing out the information in the problem set and writing down the information with appropriate notation and equations. Practice makes perfect. Next, we are going to see the examples. The problem description of the examples are available in the lecture slides. I suggest that you print or download the problem descriptions and try writing down the decision variables, objective function, and constraints on your own before watching the video clips. Do one problem at a time. Most students learn better with this starting from scratch process. I also want to give you a heads up that for students who have little experience of using notation to write equations, it is normal that you may not be able to formulate the problem correctly in one attempt. However, this skill is very important, and you need to learn to master the skill in order to do well in formulating optimization models. There is no shortcut, and the only way to learn is to get your hands dirty and learning by doing.